Good afternoon, Home Talks. Today you are going to be doing your homework over solving system of linear equations with elimination. Make sure you are writing down and pausing this video throughout the whole process. Alright, your title for this in your notes will be elimination. Your essential question is, why would you or myself want to solve systems of linear equations using elimination? Here are your steps in which you are going to go through, or any person is going to go through when solving systems with elimination. Please pause this video and get down these 4 steps. Alright, time for an example. You don't have to write this down in your notebook, but Mr. Isles is going to talk about the steps to go through this problem. The steps that go through this problem, and when we get to the on your own part, please write those parts down.
Okay, so here we see 2 equations, and we know that we could do substitution, but this one is really set up better for elimination, and I'll show you why right now. The coefficients of the y terms right here are already opposites, and you guys all know that you can add or subtract anything to an equation, and believe it or not, you can add or subtract equations to each other. So we're going to add the equations together, and here's equation 1. Equation 2 is going to be treated just like adding something like maybe 3 or 5 or an exponent, but we're going to add the entire equation together. And here's what it looks like. X and x makes 2x, and here's the key part. The y's had opposite integers, and so that made 0. Over here we just added this and got 14. Now we can solve for x, and there's the 2x equals 14, so we're going to find that x equals 7, and you know that that's not the complete answer. Remember, these are 2 equations, these are 2 lines that intersect. This is the x value, and we're ready to plug that in to one of the original equations. Actually, for right now, I'd like you to do both just to make sure that the y is equal. But when we plug it in to the first one, we find out, and there's the 7, we find out that 3y equals -9, y equals -3 after we've divided by 3. And so our solution is the point 7, -3. Had you plugged this 7 into the second equation, you also would have found, oh, yeah, there it is. Here's the first equation, and here's the second equation, and we find out that that -3 makes each equation true. Okay, so here's another system we can solve by elimination. The first thing you need to dial into is looking at these coefficients, the numbers attached to each of the variables. Not this. This is just going to kind of travel along. It's going for the ride. Here you'll notice that none of the 4 are opposite each other. But we can take equation 2, that's the second equation, and we're going to multiply it by 3. Multiplying by 3, you'll notice that we get -6 plus 5y equals 25. Oh, that's the first equation, my fault. But in the second equation, oh, wait a second, let's move on. In the second equation, notice how when they multiply it by 3, that -2 became -6, the -4 became -12y, and the 14 went all the way up to 42, because each part gets multiplied by 3. And now you have 2 equations. They're not quite opposite, but there's something going on right here. Subtract the equations. Just like in the last equation where we added equations, now we can subtract them. There's the first, there's the second, and anytime you subtract something from itself, it goes away. You'll see that in a moment. Be very careful here in the subtraction. This actually turns into 17y because you've subtracted a negative. Here we're just subtracting integers. So 17y equals -17. We solve for y, and y equals -1. Again, we take that right back up here, and you'll see some plugging in to equations. There's the substitution. Now we solve for x, and I won't go through all of that, but you guys know how to plug that in, and work your way down to the solution x is -5. And we see that that works for the graph. Had you graphed each of these, you would have found that the point -5, -1, right there on a graphing calculator, is also a way to look at this.
All right, let's try some examples on our own. Step 1, again, should already be in your notes, and you're already thinking to yourself is, which coefficient with one of the variables is either alike or opposite? So this first problem, I'm looking at the 2's. They're not alike, and they're not opposites, so let's go to the y's. I have a negative y, and I have a positive y. If I'm going to work with a negative y and a positive y, if I add them together, will it cancel out? Yep. The first thing you want to do is have them cancel out. How are we going to get them to cancel out? By adding, because they're already opposites. So 2x plus 4x is 6x, negative y plus y is 0, and 9 plus 21 is 30. All right, finish solving for x. Divide by 6 on both sides. X equals 5. Not done. We found one part of our ordered pair. Plug in for x. So 2 times 5 minus y equals 9. And we like to do the second equation as well. 4 times 5 plus y equals 21. In our first equation, 2 times 5 is 10. 10 minus y equals 9. Take away 10 from both sides. You'll have negative y equals -1. Y equals 1. 4 times 5 is 20. 20 plus y equals 21. Minus 20 on both sides, you'll get 1, and y equals 1. So that did work out for both of them. 5, 1 is our solution to number 1. All right, number 2, if you need to pause the video, feel free to pause the video. Number 2, we'll get you started, and then you should pause your video and finish up number 2. We should erase it so we can see the rest of the screen. Yeah. Okay, number 2. If we're looking at the two x coefficients, we have a -5 and a 5. Can we add those together to get 0? Yes. And that's our first step, is to do -5x plus 5x. Then 2y plus y is 3y equals 13 minus 1 is 12. You should pause your video, finish the rest of this, and here's your solution after the break. All right, the solution to number 2 is parentheses -1, 4. All right, now that you've checked yourself, please continue on to number 3. Pause your video, find your own solution, and check back in like a second when you're done. The solution to number 3 is parentheses -2, 0. All right, the last 3 problems that we're going to go over are one of different variety, because if we're looking at the coefficients, they're neither the same nor opposite. So we have to do the first step that we weren't doing before, and that's get them to be the same or opposite.
So in the first problem, you'll see that we have a 3 and a 6. We could adjust this 3 up to or down to -6 or make it a 6. We also have a y and 3 y's, which we could also adjust the y's. You have your choice. I would probably just focus right in on this 3 and the 6. So I'm going to leave this one alone, and I'm going to take this problem right here, this equation right here, and I'm going to multiply the entire equation. Now I happen to actually like opposites, so I'm going to multiply the entire equation by -2. And you'll see how this forms out this equation right here. -2 times 3 is -6x. And right there, I've built the opposite of 6x. -2 times y is -2y. And -2 times 11 is -22. I just happen to like to always add these with opposites, If you had made this 6x, we can do one of these over here. Anyway, now I have two equations, and I'm ready to add them together. Remember, this equation has been rewritten down here. These are the two equations I'm looking at right now. 6x plus a negative 6x makes 0. I'm not going to write anything there, it just cancels out. 3y and a negative 2y leaves a y. And 24 and a negative 22 makes 2. And we've already landed on y, and so now it's time to plug it back in. You can actually plug y into any of these three equations, but we would recommend doing the top two of the originals. So I've got 3x plus 2, because it was a y, but now it's 2, equals 11. And we get 3x equals 9, having subtracted 2 from both sides. We divide both sides by 3, and x equals 3. You can go ahead and check that in the other problem if you want to pause the video. Some kids are writing answers like this. Since this is 2 lines, we would prefer seeing the point where the 2 lines cross. Okay, for problem number 5 here, we're going to just get you started, and you'll see we have a 4, a negative 5, a negative 1, and a negative 2. We're sort of ignoring this for now, and we're just looking for making those coefficients opposite. And you'll notice you only have to make the coefficients opposite for one of the two variables. Getting from a 2 to a 5, not too fun, but getting from a negative 1 up to a 4 or negative 4, quite easy. So here's where we're going to focus. I'm going to take this equation, and I'm going to multiply it by 4. Pause just for a moment before we go out and ask yourself, why would we pick 4? That's right. 4 times negative x is negative 4x. 4 times negative 2y is negative 8y. And 4 times 8 is 32. You'll notice that I have a 4x here and a negative 4x here. I'm ready to add these two equations. Of course, we're skipping over this one now because we've rewritten it like this. 4x and negative 4x is, well, I'll just let you continue from here. Go ahead and pause the video, work out your x's and y's from here, and come back to us in just a moment. Okay, so the answer for this problem should be for you negative 6, negative 1. If for some reason the point you found wasn't negative 6, negative 1, go back to this step and add these back together again. Be careful always with your integers. Right in here we have something that looks maybe like a negative 13. Did you get a 13 over here? You should have. Okay, not all problems come to you all lined up in order. This problem's not too bad. We've got y's over on the left, an equal sign, and you know that this is what divides the terms. Over here, they've got these x's and these constants flipped a little bit. So you do need to do a little cleanup in there as you're deciding what to multiply by to get opposites like back in this problem. So I'm going to take this first one and just do a little cleanup. I'm going to go y equals 3 minus 2x, just so the x's and the constants line up. Now, again, we're sort of ignoring moving the constants around by multiplication. We've got a 5y and a y. Here we have negative 5x and negative 2x. What do you think would be the best variable to pick to change so that you can cancel by elimination? In this problem, you have a choice really of doing 5 or negative 5 times y. I'm going to actually do this problem by just multiplying by 5, showing you that you can also subtract equations. So here we're taking the second equation, and now we're doing a second move on it. We're multiplying it by 5. You see you get 15 minus 10x, distributing that 5 to all three parts. So we have 5y equals 15 minus 5x, and down here we have 5y equals 15 minus 10x. We're going to subtract these two equations. Mr. Isles is not a big fan of subtraction, but I'm going to give it a try. 5y minus 5y, nothing. And here you're going to want to put that 0 in to hold that place value, since it's alone on the left side. Here we have 15 minus 15, Okay, so this is working out okay. And here we have negative 5x minus a negative 10x, which is actually 5x. And so we get 0 equals 5x, and of course x is 0. I'm going to put that x right here after we divide by 5. Okay, plugging in 0 should be rather simple. After plugging in, we get the answer, I believe, is 3. And so you can plug that 0 into both of these x's, and you'll find that your answer is 3. One of the things that you notice here is we have a lot of options, and your toolbox of things you can do to equations is growing pretty consistently. Here, we just moved a few things around. We chose to multiply by 5, and then we subtracted that first equation by the rewrite of the second equation.
All right, guys, go ahead and answer the essential question in your notes. Then get back onto Schoology and take that checkpoint 4-question multiple choice, just so Mr. Isles and myself know that you made it through and where you're at. Have a great night. Bye, guys.